Welcome to more substitution examples. So for our first example, let's go ahead and evaluate the indefinite integral, the integral of sine of x times e to the cosine of x dx. So in this case, we do have a composition. So here's our composition. And e to the x, our outside function, is a known derivative. We will go ahead and take our inside function then to be u equaling cosine of x. This means then that our du would be derivative of cosine x is negative sine of x dx. We have a sine of x dx involved in our original integral. So we could also say sine of x dx is negative du. So plugging into our original integral, we are looking at the integral of sine of x times e to the cosine of x dx. I'm going to just rearrange this. This is the integral of e to the cosine of x times sine of x dx. Plugging in u, this becomes the integral of e to the u times negative du. I'm going to give myself a little more room here. All right, so at this point, we are essentially looking at negative times the integral of e to the u du. This, of course, is an integral we know. We just wind up with negative e to the u plus c. At this point, we just go ahead and plug it back in the fact that u was equal to cosine of x. And so we wind up with that our integral is equal to negative e to the cosine of x plus c. So again, here we had a composition. It was a convenient composition. We knew the outside function was a known derivative. We did have du just more or less fall out perfectly. And so this integral was relatively straightforward once we substituted in our u. Next up, let's go ahead and do another example. This time we'll evaluate the indefinite integral, which is the integral of sine squared of x times cosine of x dx. So once again, we do have a composition involved in this case. This sine squared of x is a composition. Oops, I apologize. I need to update my screen. The outside function is something squared, right? So x squared, which is a known derivative. The inside function is sine of x. So we will go ahead and try setting u to be sine of x. That means then that our du is derivative of sine of x is cosine of x, and then times dx. So plugging in, we have the integral of sine squared of x cosine of x dx. This is the integral of sine of x squared times cosine of x dx. That sine of x squared just becomes the integral of u squared. Cosine of x times dx is just du. So we are looking at the integral of u squared du. This, of course, is a known integral. Power rule, power goes up to u cubed. And then we divide by that new power. So we have 1/3 u cubed plus c. At this point, we now plug back in the fact that u was equal to sine of x. And we have that our integral of sine squared of x cosine x dx is equal to 1/3 sine cubed of x plus c. Let's go ahead and do one more example. We'll go ahead and evaluate the indefinite integral, which is the integral of cosine of 2x times sine of 2x. So in this problem, we have two separate compositions. We have a cosine of with 2x as our inside function, and we have a sine of with 2x of our inside function. But cosine is not a derivative of 2x, neither is sine, right? So this time, let's just go ahead and experiment. Instead of using an inside function as our u, let's just either pick that cosine of 2x to be our u or the sine of 2x to be our u. So instead, let's just kind of experiment. And try various things as u. So one option would be to set cosine of 2x as our u. Then that would mean that du would be equal to a -2 sine of 2x dx. And so we have in our problem a sine of 2x dx, which is -1/2 du if we rearrange the previous equation. So in option 1, we would have that the integral of cosine of 2x times sine of 2x dx is equal to the integral of u times -1/2 du. We have -1/2 times the integral of u du. This becomes -1/2 times 1/2 u squared, since the integral of u is 1/2 u squared, plus c. So we are looking at a -1/4 u squared plus c. U was cosine of 2x. So this is a -1/4 cosine squared of 2x plus c. Option 2 we would go ahead and set sine of 2x to be our u. Then we would have the du would be 2 times cosine of 2x dx. Applying the chain rule there, derivative of sine is cosine, then derivative of 2x is 2. So we multiplied by 2 on the outside. This means that cosine of 2x times dx would be equal to 1/2 du. Plugging into our integral, we have the integral of cosine of 2x times sine of 2x dx. We can rearrange this. So it's sine of 2x times cosine of 2x dx. That sine of 2x is our u. So we're looking at the integral of u. Cosine of 2x dx was 1/2 du. So we have times 1/2 du. This winds up being 1/4 u squared plus c. If we plug back in, our u was sine of 2x. So we got 1/4 times sine squared of x plus c. Now, these don't look exactly the same, but note, if we use the trig identity, of cosine squared plus sine squared. Oh, sorry, this should have been sine squared of 2x, not sine squared of x, because our u was sine of 2x. So we have 1/4 sine squared of 2x plus c. And again, note if we use the trig identity, cosine squared plus sine squared equals 1, we can get these two versions of the integral to be equivalent. Those of you who remember your various trig identities and facts may remember that cosine times sine lends itself to a double angle formula. So you could also have used a trig identity earlier on to find this integral. But since we have been working on u substitution, we took the substitution route. In the next video, we will continue to look at more examples where that u substitution is maybe not quite as obvious.